Greeting everyone. I hope you are all doing well. I'm Ahmed Khadi Mansoura, Bachelor Degree Petroleum Engineer student at Boumerdès University, and I will be the moderator of today's session. Our University of Boumerdès student chapter is honored to host a distinguished lecturer who will provide a comprehensive overview of oil and gas drilling fields and rigs delving into various aspects of the industry. Uh, he will diverse into different type of drilling bits, the features and the tools utilized across different applications and mechanisms. Mr. Khaled, do you want to introduce yourself or I introduce you?
Yeah, I can introduce myself for sure. Thanks for your brief as well. It's a pleasure for me to be with the esteemed university and the SPE student chapter. I believe it's an important opportunity for to bridge the communication and the ways between the students and the real world in the industry, and to orient you about some of the challenges we sometimes face, and also to pull the fresh talents from the students and tell you what you can contribute in the next few decades for this and this drilling industry and the challenges. So yeah, I joined this oil and gas industry with Schlumberger in 2014, and then I started as a field engineer. I worked my way up and been exposed to plenty of different type of operations, from underreaming, drilling, and directional drilling, fishing, and the whipstock, and all the sidetrack stuff, mainly based in Qatar. And then I had some jobs to execute outside in Egypt. So yeah, and until 2019, I started like handling customers back in the office in Qatar, handling the account for the bits and drilling tools. And then you heard that a lot of companies start to transition or to rebrand itself. So we were called Schlumberger, and now we are called SLB, a technology company. So yeah, this is mainly a quick brief about me, and I hope I will make today as fun and quick. I believe it's the end of the semester and end of the day, so yeah, we can dive in straight. Shall we start? All right. I'm gonna walk you through the agenda for today. Today, I prepared a few of the topics, and I'll try to keep it as simple as possible, given the fact that many different backgrounds we have in this call. So we start why we drill for carbons, why they are important. Then we'll talk about the rigs in general, the operations and the rigs, the tubulars that we use. Then we can go to the drill bits and see, tell you about what are the equipment, how we can select our drill bits for each application in general, and the mechanism of the drilling. Also, we're gonna talk about jetting operation, which I find sometimes interesting, and it's really critical operations. Also, the very well-known MWD tool, which is the measurement while drilling tool, which is needed to give us and tell us the signal from the downhole to the surface, and tell us in which direction are we going. And then we have the whipstock operations. We're gonna talk about like why is it important, and also the underreaming and what value it brings to the operation. In conclusion, we're gonna talk about the drilling scope and what are the challenges that are facing nowadays, and how we will maintain the drilling operations during the transition, the energy transition. As you know, this is the energy landscape, and in few decades from now, we are expecting to have zero emission and the decarbonization. All of these trends are now like being the headlines in the media and within the corporates. So it's very important to know and orient ourselves in which direction are we going through. So I'll start my presentation today with a trivia. And I believe some of you are are familiar with this picture. If you know what is it, just drop me like an answer in the chat box quickly, like within 5 seconds. Any takers? Oh yeah, here we go. Okay, so let's not to spend more time on that, but this is the well-known catastrophic event that happened in the Gulf of Mexico, where the operator was the British Petroleum. And I think you watched the movie, The Deepwater Horizon. Also, it was released sometimes back. So, but do you have any idea what was the main cause? Like, it's definitely several causes, but what was the main cause? And here I'm just gonna tell you some of the options, and you can select one of them. Like, was it fast ROP in drilling, or a kick while drilling, or poor cement barrier while abandoning the well? So what will be the most, I mean, something that you can relate to or you think it is the answer? So only Yahya here is answering a kick while drilling. Who else can tell me? There is nothing, I mean, nothing wrong in just picking up an option. All right, fast ROP. Okay, in fact, it is the third option. It is the poor cement barrier while abandoning the well. So I invite you all to read about the case for this Deepwater Horizon. And basically, the British Petroleum was behind the schedule. They need to abandon the well and move on to the next. And they did the cement job. And unfortunately, the cement job was really poor, and it did not really act as expected. And what was the cause? And the answer: the annulus cement and the shoe track barriers did not isolate the hydrocarbons. So what happened is immigration of these hydrocarbons into the well, and the methane gas went all the way to the surface, and it catch a spark, and it ignited the well, ending with this catastrophe and the major oil spill. So poor situation awareness is also one of the factors, but we are talking about the technical reason why it happened, and I just put the reference here that you can refer back to in the for British Petroleum report. All right, guys, if I'm going quickly, just stop me at any time, and I'm free to answer any question that comes up. All right. So why do we drill? Why is it important to drill for hydrocarbons? I believe we are familiar with the drilling for water wells, and in many countries they are having a shortage of resources of water. So we end up having like a water well behind, like around the hoods and around the our buildings. So water wells is also like well known in the field. Also drilling for building foundation. If you are driving around your cities and your towns, you can find this heavy machinery with this spiral shape of equipment. They drill in vertical in order to pump cement and put the steels and go high with the building. So it's for building and construction industry. However, when it comes to hydrocarbons, this the magic you will see with this land rigs, right? So drilling for oil and gas, it's mainly because the hydrocarbons are located below the Earth's surface, as everybody knows. They exist in porous and permeable rocks called reservoir. I believe in French you call it reservoir. And these reservoirs can take many shapes, right? And forms. So based on the shape and forms, the engineers and the operators decide to drill in a certain way, either vertical, deviated, or horizontal. And it depends also on the application. Okay. So the need for hydrocarbons is a necessity to power cities, energy for factories, as you can see. If we don't have fuel, if you don't have the power for the factories, the economics will collapse. District heating, and you know that many countries are relying on the district heating in winter season, and they are relying on the gas export for major exporters here, around the globe. So district heating is one of the also purposes to use and consume the hydrocarbons, especially the gas. The byproducts for transportation, gasoline, kerosene, you name it, diesel, anything, all of these byproducts are needed for commuting and for transportation means. And the other appliances around your home, the households, you have everything has consists of plastic and PVC, polyethylene. So all of these are byproducts of these hydrocarbons. And also, I quoted something interesting from SLB is to create amazing technology that unlocks access to energy for the benefit of all. So basically, this is what we do. All the engineers get together, bring technology, bring value to unlock these access of energy below the Earth's surface for everybody's use, right? So the shape of reservoirs. I believe that the petroleum engineers here are very familiar with this schematic, and also everybody who is interested in oil and gas. So drilling can be conventional, similar to this rig, like drilling in vertical, or it can go horizontal based on the shape of the reservoir. So you can see here it goes vertical and then it builds up, and then it goes in tangent or nearly in horizontal. And also for this one, for example. So why is that? Because the reservoir is basically placed in a way that is taking this horizontal shape. And the reservoir characteristics, it is consisting of permeable and porous rocks, right? So if you look at a sponge or anything that has porous porous characteristics, so these porous vacancies of and inside these rocks are what accommodates the hydrocarbons. However, when looking not only on the reservoir rocks, but we need to look at also the cap rock. So the cap rock is necessary to seal to play as an effective seal above the hydrocarbons reservoir in order to keep it in place and prevent it from escaping to any other direction. And the hydrocarbons are normally found mixed with oil with water or oil with gas associated together. So this is the nature of it. So this is in principle, whatever, like when we drill, we expect to have a cap rock and then the reservoir comes below it. And it should be permeable and porous rock profile. All right. Now let's go back to the surface with the rig tubulars. The rig tubulars are something very essential in our industry, in our drilling, and they are normally provided by the contractor. And there are three main types of them: drill pipes, heavyweight drill pipe, and the drill collar. So what's the difference? So the drill pipe, as you can see, it's a slick design, very simple, with a pin and box connection. This is what we call a pin and box. And then it just like adds flexibility to the string. It's connected with the BHA, and it allows us to go far destinations below the Earth's surface, even for extended reach distances. Now, this is for the drill pipe. If we want to add more weight, so we go with something is called the heavyweight drill pipe. So the heavyweight drill pipe, it just like adds more weight to the tube that we're using, and it adds some flexibility. So you don't want to add stiffness, but you need more weight and flexibility. So your choice will be heavyweight drill pipe. For the drill collar, it is very stiff and it is hard, and it adds more and additional weight in comparing to the other tube. All right. So normally we use them as a combination on the rig floor. On the rig when the operation is about to start. So we design our BHA, which is the bottom hole assembly, in combination the drill collars with the heavyweight and the drill pipe all the way to the surface. So that's in general. Next is once we are about to start our operation, the rig should be in place and should be in location. So what happens is that the rig crew is responsible to prepare these tubulars, and they make up these tubulars in a set of 3 normally. So tubulars are racked back. This is how we call it, in the form of a stand. So if you can see in this picture, this is the rig floor where it is, and then all the way up is the derrick. So all of these lines that you see are basically stands of heavyweight drill pipe or drill pipe or drill collars. They are made up in a set of 3 and kept on standby for the operations. They are definitely secured safely in order just to be ready whenever the operation will start. We start making the connection with our drilling tools, and we start going down and start drilling with these tubulars. All right. So Since we talked about the land rig now, let's talk about more types of rigs that exist in the industry. We have the drill ships, the semi-submersible rigs, the jack-up rigs, and the drill barge. If we want to if we want to know about the differences, so every different rig is designed or it is made for different geography and different depth. So in general, the drill ship is for ultra deep application where the seabed is extremely deep down in the water. And this is where we are like the operator prefers to use the drill ship. In other location, it is less deeper and they go with a semi-sub. By its name, it just like it floats, but it partially floats below the sea level. And it just maintain its position by means of anchors or thrusters connected to the GPS. Other forms of jackup rigs, if you ever flew above in the Gulf region around Saudi or Qatar, you will find plenty of these rigs in the Gulf area. So it's very popular in the shallow depth where the three legs are down immersed down all the way down into the seabed, and they jack up all the rig to a certain height above the sea level in order to start the operation. So basically, it is anchored and supported with these three legs. No matter what storm it is there and all the high waves, it can stand still without any issues. Drill barge are, as you can see, it is next to the land, like around the mangroves or something, or inland sea. So it is mainly for very shallow application near the land. So rigs are essential to carry out our operations, exploration, appraisal, or development of the oil and gas. And as we said, depending on the geographies, if you go to the Mediterranean, you will find something different. For example, like whenever you explore new fields or you develop fields in oil and gas, so you must see like most of the time you see a semi-sub and drill ship in the Mediterranean Sea. The rig will be selected for suitable needs based on that. All right. And the common transportation. So how we used to go to the rigs is by means of helicopter, chopper, and the tools, equipment, and food are normally supplied by vessels. All right. And like normally these jack-up rigs can be jacked down and floating above the sea level, and then there are vessel and tugboat. They are pulling it to another location for another exploration or development wells. All right. And in perspective, like rig types in perspective of the depth, you can see that the drill ships, they are operating ultra deep, 12,000 feet or 10,000 feet for the semi-sub, 500 feet for the jackup, and really in shallow waters for the barge. All right. Let's now talk about the drill bits. I hope everything is clear, and if there's any questions, as I said, you can stop me and you can drop it in the chat box, or we can open the ground for Q&A at the end of the session. So for the drill bits, we have the first type, what we call a roller cone bit. This comes at the bottommost in the BHA. And we have two types. We have the mill tooth, which is symbolized by empty, and we have the TCI bit, which is the tungsten carbide inserts bit. All right. But what is the difference? So the mill tooth, and the way it is manufactured, it is suitable for soft application, such as top hole or cement clean out runs. Okay, most like ideal for this type of applications. However, if you are looking for more competent drill bits and more challenging formation, you will definitely need to look at the TCI bit, tungsten carbide insert. The tungsten carbide is a very hard material. If you can look it up also online, you will find that it is very hard material, and these are ideal. This bit TCI is ideal for casing shoe drill out, motor runs, or interbedded formations. What's the difference? Like some of the operators may tell you like, okay, I need a dedicated run with a TCI bit in order to preserve any damages of the next run with any other bit that comes for any subsequent run. So basically the TCI is ideal for this kind of application. Also for the motor runs and any run that you have like a very like challenging formation and you need to slide with a motor and build up the section. So you need to look really at a TCI bit, which is ideal. Also the interbedded, as we say. What do we mean by interbedded? If you have a look at this photo, it looks like it's a mix of like clay, like shale with carbonates and limestone all together. So they are like consisting like of layers that are connected together in a certain way that form interbeds. So this gives more competency to the rock, and we need to really consider a harder or stronger bit in order to drill through that. The roller cone bits feature, as it says by its name, it consists of cones, like 3 different cones. It has the 3 cones, the most popular ones, like you have 3 cones here. However, you can see some bits have a double cone, but these are nowadays, I mean, I'm not really sure if they are popular, but the most likely is the 3 cone bit, the tricone bit. It has also the inserts, so or tooth. So the inserts are these, and these are the tungsten carbide insert, as we said, and they are pressed into the cone. Like this is how they are manufactured. But for the tooth, they are machined in a way with this like a tooth shape, the zigzag shape that you saw in the previous slide. Now the shirt tail is just like this part that is at the last part of this beam holding the cone in its place. You have the bearing. I believe if we have any mechanical engineer here, they will understand what they will know what is a bearing, and also other engineers for sure. So the bearing are the component that allows the smooth rotation and the movement of the cone itself back and forth and rotational manner. So we have 2 types here. We have the roller bearings and the ball bearing, and the type of bearing may differ. The more we go with larger size of bit, or the less we go with the smaller size of bit. So it depends. The bearing may be different for each size. And the last is the lubricant reservoir. Is basically here. This is the reservoir where we place like the grease or the lubrication, because the bearing needs some lubrication since there's a lot of friction happening there, and we need to keep it like to prevent it from wearing out very quickly. So this is kind of like a closed system that allows a good lubrication for the bearing. So this is in a very brief way about the roller cone bits. Let's go to the fixed blade bits. So the fixed blades are like different types. They are made from diamond, manufactured like synthetic diamond, not natural one. However, there is natural ones, but here we're gonna only shed the light on the manufactured one. Crystalline diamond compact, the PDC. They are designed for highly competitive formation layer, and also for vertical or directional. And they are common for faster drilling and high performance. So whenever you go deeper in the well, and whenever you have very competent formation and you are looking for high performance, so the very straightforward way is to go for a PDC bit. All right, let's start with the features. So I intentionally put like 5 blade here, 6 blade, and 7 blades. When we talk about the blade, you are talking about going either aggressive or if you want more durable. So aggressive, but it's not a trade-off. Meaning, like if you are going for aggressive, it doesn't mean that you are going less on durability, but it's just like to visualize and to understand the concept. If the formation is very soft, you need less, probably you may need to think of less number of blades to drill your formation with, right? So it gives you some more aggressiveness, and it can accelerate your drilling speed much more. However, if you are drilling into a very competent formation, you may look at something different. You may look at durable bits with high number of diamond into it. So maybe you may look at 6 blade or 7 blade bit in order for your application. Second thing is number of nozzles. So ideally, like each blade should have 1 nozzle, but number of nozzle can be different for also small size of bit, like depending on the size of it. but it is important because these are the nozzles that allow this hydraulic energy to exit from the bit and evacuate all your cutting outside and to the surface. First outside and then to the annular and to the surface. So the drilling engineer really need to look at the how to optimize the hydraulics to give him enough energy to evacuate this cutting while drilling, and also to offer him the needed pressure drop for your systems, for your RSS system, for example, the rotary steerable system, and the MWD to function properly. If you don't have enough pressure, you may have a problem, you may face problems to function and operate these tools. So this is very important. The junk stop area is basically the area between these two blades, for example. So why is it important? If we are looking at some like a sticky formation or shale sticky formation, so this formation is having more tendency to accumulate and not to evacuate very smoothly, similar to the others. So what happens is when you accumulate, when you have a lot of like cuttings here and they cannot escape due to this small, for example, looking at this, it's very small compared to the other 5 blade or the 6 blades. So what happens is that the drilling efficiency will drop because you're not really cleaning these channels. So what happens is something that we call a bit balling. I don't have a picture for it, unfortunately, but you can look it up. So when you have a bit balling, it will affect your ROP. And the ROP is something very essential while drilling because it is the drilling speed, rate of penetration. So something to consider for the junk slot area. Also, the cutter size is that these elements, not sure if I can zoom it in, these elements consist of like the diamond, and they have a certain size, and normally it is measured by millimeters. So if you are looking for an aggressive diamond size, you may look for for larger size of millimeters, let's say 16 or 19. Or if you want it less aggressive and more like less aggressive to enable to in order to be able to place too many PDC on the cutting structure. So it depends on your application. So you may need to figure out what is the number of blades first of all, and what is the cutter size that you need, right? The backup cutters. Now, if you look at these kind of like bits, you can see like a backup row, right? So these serve as, as it says, it's a backup. So if there's anything wrong went with these, it get broken or it chipped. So the next row will serve the purpose, and it will make the work done, right? So this is where we look at this when we have kind of high impact application, when we expect more breakage of these PDC elements. So we need to have a higher volume of diamond placed in a single blade. This is when we are looking for the backup cutter. MDOC and low vibe. If you look at this bit, you can see that there is something that looks like your knuckles, your hand knuckles, and straight after you can find kind of a dome shape. So these are kind of, sorry, these act kind of like to manage your torque while you drill. So they act, and I'm gonna explain about it in the next slide. So it's very important to maintain your torque in order to maintain your also your directional demands, because having unstable drilling with a lot of torque and vibration will really affect your drilling. The gauge pad, the final one is, you can see that this gauge pad is extended in comparing to the other bits. So each application may require different extension of this gauge pad. Some directional needs or demands need shorter gauge in order to be able to navigate and to geosteer into the formation. So maybe you need to look at shorter gauge, or some operators would like to maintain a good hole quality. So you look for an extended gauge bits similar to this red one. So that's in general. Let's look at this quick video, and you can see this is a PDC bit, how it is interacting with the formation. It's just like scraping and shearing the cuttings, the layers. And in compared to the roller bit, you can see that these are the TCI bit, how they are crushing the formation. So they are totally different mechanism when you look at it. So let's talk about this MDOC quickly. You have these two bits. We have the domes and you have the knuckles. So as I told you, it is meant to minimize the excessive depth of cut. So if you are putting a lot of weight, so the diamond may really bite into the formation more than the needs, right? So this will create a lot of torque and a lot of force that can break your cutter. So in order to mitigate this, we place these knuckles or this feature, the MDOC feature and the low vibes, in order to limit the depth of cut and reduce the torque, minimize the breakage, and maximize the bit life, basically. And quickly running over the bit feature or the bit profile, the bit has a different zone. You have the cone, which is, let me put the pointer here, will show better. So that's the cone, all right? And then comes the nose, which is the topmost of the bit, then the shoulder, and then the gauge. And I believe we covered all the features in the previous slide. So this is in general, when we look at the bit and we see how we can differentiate in order to dull grade the bit after we run it. So we look at different areas. This is the cone, and then the nose, and then the shoulder, and the gauge. All right. You have seen the junk slot area, the PDC cutters, the fluid cores, and the rest of the features. So that's in general summarize our bits. What do we have next? The cutting mechanism, as you saw in the video. For example, you can have a look at this, the PDC, and when it is like forced into the formation, it has a bite, and then with the rotation force, it starts shearing the mechanism, removing a layer. In contrast, when you look at the roller bits, those inserts are making indentation, cracking, and crushing the layer or the rock layers, as you can see here. So they are looking at two different mechanisms for each bit. For the jetting operations, this is something really important as well. And when it comes to top hole sections, and when we need to directionally drill and deviate from the vertical. So what's happening here, the jetting operation are applied when there is a need for accurate drilling. What do we mean by this? Normally, when you have the BHA and you have the drill string, you rotate from the surface and all the entire drill string will rotate with you. However, if you're having a neighboring wells and a very soft formation like around this area, it's very critical to maintain your projection of the well and this section. Like you want to drill from point A until the total depth, for example, and you don't want to disturb the entire interval. So what do? Is that you use a bit with something that we call a vectored nozzle. So this vector nozzle is installed on the bit, okay? And it is pointed at a direction. The engineer on the rig site will really know in which direction this is going to. And it is exposed into a certain direction, and they pump a high flow. So this flow and all this hydraulic energy is like going at a certain point, making this cavity, and then you can start sliding with slight rotation. This rotation is not like the normal, like you go to a higher revolution per minute RPMs. No, you go very soft, like 20 RPM for a limit for a certain time, and you get to the depth, and then you continue doing the jetting operation. So the main purpose is not to collide with a neighbor well or with adjacent well, which is called the anti-collision risk. Looking at this picture, this is what we call when you have an anti-collision risk. You have a lot of neighboring wells, and you need really to manage your directional drilling without disturbing the entire system. All right. So the advantage is improved accuracy in drilling. This is what we are trying to achieve here. Controlled cutting removal and minimize vibration. Why do you think it's controlled cutting removal? It's basically you're not really drilling and using the entire capacity of the drill bit. It's only by means of the spraying or this a projection of this hydraulic energy to a certain spot, and also minimize the vibration because you're not rotating the entire string. All right, except like for minimal use. So talking about the measurement while drilling. What's an MWD? It's a measurement while drilling. We just said it. That's the BHA that looks like drilling in horizontal, obviously. You have the bit, you have the stabilizer, and then the mud motor. The mud motor is used to just add more rotational speed to the BHA. And then we place the MWD, for example, then the rest of the BHA. So the use of the MWD is it helps you to take the survey, which consists of the inclination, the azimuth, the depth, and a lot of other drilling parameters that the drilling engineer will use in order to know in which direction are we going. So let's define what is an inclination of the well. If you look at this picture, you can see we are going from vertical, and then we are starting deviating. So this deviation is an inclination, right? So it's a deviation from the vertical. And you have also the azimuth. The azimuth, if you consider that this is the north, basically the direction to the north, so any deviation from the north will give you the azimuth degrees. So both the inclination and azimuth are measured in degrees. So if you are in the first quadrant of this circle, you may call the azimuth is 90 degrees or even less, maybe 45. It depends. So basically, this is what the MWD does. It gets you the inclination, the azimuth, the depth, and also it has the ability to measure relative shocks and vibration. Why is it important to measure the shocks and vibration? Is basically the MWD is telling us that you are putting a lot of parameters, a lot of weights, higher speed, you need to slow it down, for example. Or it can give you like a higher magnitude, like a slow magnitude of shocks and vibration that is telling you like you can accelerate and you can add more parameters to optimize your performance. So it depends on what the MWD is experiencing downhole, and it gives you the signals. But how does it work? The tool has magnetometers and accelerometers embedded in the system, and they are calibrated before sending it to the job. It is meant to measure the inclination, azimuth, shock, and vibration. It sends the encoded information to the surface by something that we call a mud pulse telemetry. So what does it mean? It means that it has kind of like a system that generates pulsation into the mud that we are drilling with. So these pulsation are travels back to the surface, and they are representing kind of like a coded information, and it can be decoded on the surface on the screens of the driller and the directional driller, and it gives them all what readings they are expecting to, and tell us like, oh, we need to steer in a bit, so let's send the command, the next command, and let's steer to the right, let's steer to the left, or let's drop or to build. So it depends on the trajectory in which the MWD is giving us. This is in a very simple terms. All right. So talking about the whipstocks, I believe this is the most challenging part, and it is nice. It is something nice. I worked with the whipstocks a while ago. So the whipstocks are used for sidetracking the mother hole to a new rat hole formation at a selected depth and interval. You can see I put here a photo that has a tool. This is called an anchor in general. And this is the mother hole, what we call the initial hole that we drill. And the operator wants to sidetrack to create another hole, another drain, let's say, from the mother hole, and they go with another drilling and they drill a new rat hole. These are the namings that are normally used in the oil and gas field. So a rat hole, that means like a new hole to be drilled. Excuse me. Here is just a picture for engineers measuring the tri-mill, which is a component of this whipstock, which I will cover soon. So the question is, why do we sidetrack? So why do we sidetrack is when we are targeting another reservoir zone or zones. Remember when we talked in the early beginning that the reservoir can be existing in a certain depth and there might be another reservoir laying on top or in the bottom, or possibly the production capacity or the production rate of this existing reservoir is dropping over years, over 20 years. So in order to to save some money, and instead what we were talking about is the tri-mill. It consists of lead, follow, and a dress mill. And now you're gonna see in the video why there are three mills and how does it work. All right, that's the whipstock slide that we talked about. And it can be oriented in either directions in order to depart the well at the direction that we need to target the next reservoir, for example. So once the orientation is done, below the whipstock there is something is called the anchor, right? So a pressure is applied on the anchor, and then it deploys. It as these slips and anchored, it deploys to set it in place, so it doesn't allow any rotational movement or any dislocation movements, right? The mill is normally attached with the whipstock with a kind of like a breakable or shearing bolt. And what you see here is kind of like fatiguing this bolt in order to detach it from the slide to start doing the milling and to start doing the sidetrack, all right? So the mill starts to interfere with the steel itself and also with the casing. And someone may ask, how can we make sure that the mill is going to exit the steel? Because both of them are steel. You have the whipstock and you have the casing. But the grade of the steel of this whipstock is higher than the one for the casing, all right? So the whipstock pushes the mill outside, and the mill is like being operated from the surface. They apply weight and rotation, and it reaches half the way, and it keeps pushing itself to sidetrack from the main hole. So what's happening now is we were milling steel, and you see all these swarfs are coming from the bottom of the hole to the surface, and now the mill is going into the formation. All right. So what did the mill do? It basically created a window, or you can say it like if an infinite, through the casing in order to create this sidetrack and maybe elongate it a little bit more. And then we go with the next drilling BHA and to continue our drilling. So this what happens is that we isolated the mother hole and we drilled a sidetrack of this hole, right? So this sidetrack is something known for a long time, and also it was used before even having directional tools that can go in directional manner without, I mean, intervention with the steel or those mechanical stuff. But then it is still used in current operations and in modern ages for these kind of like use and benefits. So jumping to the underreaming, all right. The underreaming has many values to add to our operations, and they are used either while drilling or on a standalone application, basically to enlarge the hole for various reasons, such as unstable formation intervals, something similar to swelling shale. If you know about the shale, that this is a picture about similar to a shale. When you drill into this problematic zone or unstable zone, what happens is the shale reacts with water. The mud is in many countries is water based. So when the shale like gets in contact with water, it swells over time. So once we finish drilling, what happens is this hole that we drilled, whatever the size is, it gets tighter on us, and we may get stuck because of that. So what we advise sometimes to run in hole an underreamer in order to deploy the cutters, and this is the way of the drilling is from bottom to top. You can see and you can notice that this is the hole clearance is larger than the bottom. Okay, so basically what happens is once we enlarge the hole, is we are giving ourselves more clearance to the BHA in order to reach our total depth, our TD, and then be able to pull the entire BHA to the surface without getting stuck, because it's a factor of time leaving an exposed area of shale, okay, with water which can swells over time. This is the first kind of like type of application. The second application is called key seats. When you have a key seat, what's happening basically is because of the hard curvature that you see here, is that the drill pipe are getting pushed to a side to the side by the means of the side forces that we see during drilling. So what happens over time, these drill pipes are all rubbing against the borehole wall. So they make a shape of something similar to a key seat. So this can cause kind of like stuck scenarios, or even if you are having drilling an extended reach well, you may have an issue with the key seat because you cannot really drill for deeper intervals, because the key seat is the problem. It's limiting your motion of the drill string. So what happens is we go with the underreamer, and then we can remove the area out and the interval in here by means of these kind of tools. Also, we have another third application, which is for the sake of casing with centralizer fitting. Sometimes we drill holes, but they are not enough to accommodate the casing with the centralizers. So what we do is we drill a normal, like let's say 6-inch hole. And then if we want to run, for example, a 5-inch liner, so the clearance between 5 and 6-inch is very narrow, and it will not be enough for a good cement job after that. So what we do is we drill with the 6-inch, and then we enlarge to something higher, possibly 7, or something around that, in order to make the centralizers and the casing to fit into the hole that we already drilled. So the advantage is compatibility with the directional drilling application. Nowadays we can add these tools to our directional BHA. We have improved reliability, and it saves operation and rig time. As you can see, we can eliminate the stuck scenario. We can eliminate the key seats and all of this. And also it is adjustable opening size based on the requirements. So basically we can adjust this opening to variety of inches and sizes based on the operator requirement. The jarring operation, I'm gonna go quickly on this because we are already completing 1 hour. The jarring operation happens when we get stuck. So basically, the jar makes and generates an impact wave. The jar generates an impact wave that propagates through the string towards the stuck point. All right. So the jar shall be placed between heavyweight drill pipe and drill collars to operate effectively. So a jar is kind of like a safety tool. It operates with it has some detent system inside it, and it creates a firing and a blow wave that propagates along the string, and for any stuck scenario. So if I'm drilling and we finish the section while going up, while pulling out of the surface, and we got stuck while going up, the first thing that we do to reassess the situation is we need to fire down in order to recondition the hole properly and be able to pull free the string, and vice versa. If we are tripping in hole with a new BHA, and while tripping in hole in the open hole, we got stuck, then we need to think of firing backwards. Firing up is not to get deeper into the problematic zone, to condition the hole and reassess before continuing. So the jar is very essential tool in every drilling BHA. A stuck scenario can be mechanically or differentially. What you see here is a mechanical stuck. However, the differential stuck is when the mud weight, because the column is the hole is full of mud, right? So the mud could be exceeding the pressure of the formation pressure, and what it does is just it pushes the drill string towards one direction of the well. So this causes also something that we call a differential stuck. So the first thing that we start thinking about is to fire the BHA to release, or we can circulate to change the mud weight to something different, to less weight, in order to balance the situation between the formation pressure and the hydrostatic pressure. Now, this is the questions. I'm not sure if we have time to discuss that, but what happens if drilling BHA got stuck and joining was unable to recover the string? What happens is that when you got stuck and you spend 24 hours or maybe 2 days trying to fire the jar without progress, what you will do? Normally, operators think about pumping acid. If you pump acid through the BHA, it will just like remove all the problematic, the acid is just like eats the formation and it dilutes everything in the formation so that we can pull free. If even the acid was not a good remedial plan, what will happen is they may think of running a wire line into the drill string and go to a point where they think they are free, and they make an explosives. They make like kind of like ignite, and the drill string will be parted. So they will claim and will declare that the BHA is lost in hole. Then they pump cement, they clear it, and then they may go with the whipstock, for example. This is a part of the solutions. Or they may go with the open hole sidetrack with some cement, and then they sidetrack. So it depends on the situation. So unfortunately, the jar can really help us in releasing the string, but sometimes it gets worsened. The problem may be really complicated. Trivia, another pop-up question in order just to really to get some interactions. So do you know this is the like what do you call a bug, all right? The ladybug. So, do you know when did the term computer bug was originated in our history? If any idea, just drop it in the chat box. Okay. 90th. Could be. I think it's older than that. All right. No answers, no takers. In the 80th. Could be, but the origin of it, the first recorded instance of a bug causing a technical malfunction occurred in 1947. All right, it's that old. So engineers, it's the fun part is the engineers working on the one of the computers in Harvard University. What did they find? They find a bug. Can you believe that? So they found a moth, something that's very cute. Just like Google it, and you will find kind of like a very microscopic a creature. They found it like stuck in a machine hardware, causing this malfunction. And from there, it started called like a software bug or debugging, or like every update of any Apple device or iOS system, it tells you like removing the bugs in the system. So there's not like really bugs in the system, but it was first originated because there was something stuck in those huge computers back in the day when the computer was occupying 2 rooms or stuff like that. All right, so this is something that just as an introduction, because now we are going to conclude our last part with the new digitalization era. So talking about the autonomous drilling, it is something very interesting that's happening now, and the direction of all the companies are going towards the autonomous drilling. So what does that mean? So you have normally we control the drilling on the rig, and the engineers are on top of it. They can control the tools, and they need to be awake with 12 to 12 shifts. But with autonomous drilling, the idea is to have all the programming embedded into the system, and it's a pre-planned job. The system goes and start drilling autonomously. Just like Tesla cars nowadays, they just can take you from point A to point B to the market or grocery without a single driver. The autopilot of the airplane is the same thing. So the autonomous drilling is like really removing the needs of being of having a system being monitored by human to optimize and to have more efficient drilling. So efficiency in decision making. Already the system will know that there is a geohazard. We need to take decision ahead of time. So it by itself it takes the decision to steer and do the geosteering, right? So in general, it saves rig time. I'm not sure if are you familiar with this graph? What does this graph showing for directional drilling? Any idea? Hmm. Any thoughts? We talked about when the DD is trying to send command, right, to the rotary steerable systems. So what you see here is a bit, and then the system, the rotary steerable systems, then the rest of the luxury smart tools, then all the way to the surface. So in order for this system to steer, to make to take orders, something needs to be commanded from the surface for this system to start taking decision or given making the order. So this graph is basically showing something called downlinking. So this downlinking is basically when the driller is trying to send command from the surface down all the way to the tool. They play around with the mud flow rate, and this is the basically the pattern in which he need to increase the flow, then decrease the flow, increase and then decrease in a certain pattern. So this pattern, when it reaches with the mud being pumped all the way to the RSS systems, they take it's already receiving this command, and in the tool it's already knowing like what is this command for, to turn or to drop or to build or to steer away from for a direction. So this is called a downlinking. You will see a lot of these stuff if you ever went to a job with a directional driller. So what we are trying to do with the autonomous is having this command is being already taken by the system itself ahead of time to save the rig time and to save the operations. Maybe I'm not the best one to explain this initiatives because it is really in the early stages, but this is the direction that the industry is going to. Well placement and reservoir mapping. This is a really a wonderful tool that can really show us a real map of where the hydrocarbons are preserved. You can see this thin line, the black line, is basically this is the well drilling through formation, drilling through the reservoir formation. So you can see here also, this is another 2D map showing the well placement is optimized placement on top of the reservoir, and basically the hydrocarbons are showing and labeled with like reddish to maroon color, where you see the water is colored with blue. So these are two different mediums with the waves and all the pulsation coming from this kind of reservoir mapping tool. It gives us where the resistive medium is and where is the conductive medium is. So the resistivity reflects the hydrocarbon placement, and the conductivity for the water. Correct me if I'm wrong, but this is the idea behind the well placement. So first of all, when in all times when they used to do the seismic data, something in Arabic we called المسوح الزلزالية. So the seismic data is used to explore where the potential hydrocarbons are located. Now we can really map it with in real time while drilling, and we can see where the hydrocarbons is sitting. So this is we optimize our well placement. So what happens is, it tells us exactly how long we need to drill, and is there any need to keep on drilling, or there's no more hydrocarbon in this, so we can stop drilling. So this can optimize the operation, overall operation, and reduce definitely the carbon being emitted with these elongated operation days. Another initiative that most of the service companies are interested in is the geothermal energy, as also like getting like attention of a lot of operators. So geothermal is one of the resources important for in this transition area, transition period. And also the last thing I want to talk about is the CO2 capturing and the blue ammonia production. Some countries have a lot of natural gas, similar to Qatar, for example. They use the natural gas to produce blue ammonia. In the process, the byproduct of this process is CO2. So nowadays they are thinking of drilling wells in order to store this CO2 into the wells and capture it. So and the blue ammonia will be used as a low carbon fuels for all the industry, marine power and industrial needs. So this is kind of like initiative is being nowadays. We can hear it from Qatar, from the Emirates, from everywhere around the world where they have natural gas as a resource. So this is in general about the our role in the drilling and the transition and the energy landscape, and what are we expecting in the next few decades, in which direction are we going. So this is part of what I prepared for you today. Probably I took a lot of time, but I'm happy to answer and address any questions.
Thank you, Mr. Khaled. Let's see
You're
if
welcome.
there is any questions. Everyone, don't hesitate to ask questions to Mr. Khaled.
Sorry, I lost the chat box. If you have seen any questions, let me know, because I cannot see it. I don't know why.
Okay.
I don't know why. I see. All right. Seemed everything was clear. I mean, it's sometimes really difficult to to talk about every single information, giving the short time and giving the backgrounds of too many attendees. So we need to take it into consideration as well. But really, it's very interesting, industry, and I'm happy to answer anything.
There is a question from Yahya.
All right, there we go.
How are we from achieving geothermal energy extraction like oil and gas, for example?
How are we from achieving geothermal energy extraction like oil and gas, for example? All right. So currently, the geothermal is existing, right? It is there, and it is helping us in the transition. So the geothermal is nothing, is not like extracting this, something from below the earth surface and to consume it. It's basically we are extracting some of the fluids in order to put it into the power generation, right? So so it is existing. Probably it's not that really vast because it's something new. So we need to consider in mind that the oil and gas was discovered like back in like long time ago, and nowadays these initiatives start to take place. So um, I'm not really sure like I mean it's not gonna really eliminate the extraction of oil and gas. It's still we are in the transition period where the mix of all the, the energies are needed, right? Or the success rate and technology used. So basically, what we are currently using for oil and gas drilling is being used for also the geothermal, but also given the fact that we are drilling through like a high temperature wells, like you call it HTHP, high temperature, high pressure wells. This will definitely need some special technology associated with it to be used. You have like bits that need to be like heat resistant, and it does not really get affected with the heat. All the rotary steerable systems need to be rated to really to take and absorb this heat for drilling such and such application. Also, the cementing need to be a special kind of cementing to seal the well and make it a good integration. There's a lot of like papers and journals out there for the Schlumberger and others operator who have published these success stories, so you can have a look at it. What are the main challenges faced in the oil and gas industry? All right, this is a very wide and it is yeah, it is a very to answer this, it has many challenges actually. Before we had the luxury to just drill over the land and extract the oil. Now the challenge starts when you go offshore. When you go offshore, you are having a rig spread rate, so the cost of the rig per day is really massive, right? So you need to account for these. The cost is a challenge for offshore. Deep water is also a challenge for some application. Gulf of Mexico, for example, or Southeast Asia. There's a lot of challenges in there because nowadays we try to save the time as much as possible for drilling. So normally we drill with the normal BHA, but nowadays you can hear the initiative of casing while drilling. Why do we do this? Because we need to eliminate some flat time while doing these projects. So they go with the casing and they drill with the casing and they set the casing at a certain depth. They continue drilling. So in this way, they save time of pulling out and running back and such a problematic zones. So there are plenty of different challenges in there, and every single domain, they are trying to improve the efficiency. What are interesting project topics that the current industry is more interested with? Nowadays, so the projects they are most interested is the autonomous drilling, the AI trends, all of this, the machine learning. They are all of this like going into a direction to optimize the drilling, minimize the human error, all right, save the rig time as much as possible, reduce the need to expose people to such a hazard. So all of these, like when you have autonomous drilling, so we don't need really to send all like a lot of rig crew to be exposed to such a harsh and risky environment. So you reduce the number of people. So there is a lot of interesting projects nowadays. Geothermal is one of them. The reservoir mapping is one of them. What else? This is what I can remember or recall. But as I told you, there's a lot of investment in many domains. Probably I need to do my search in order to give you a proper answer for that. But no, thanks for the question. Okay, Yahya has a question. When opening up windows of directional drilling from one section of the well and then sidetrack, will the well be weakened and how we can avoid collapsing? So you are talking, Yahya, about this sidetrack, about the whipstock, right? Or about the normal sidetrack in open hole? Or maybe Fakhruddin, can you elaborate more? Drilling many wells from one window. Normally deviated wells. Normally, the case is always to drill one well per window. I don't really imagine, or I can't really would really imagine to have or expect many wells from a single window. So normally what I showed you in the sidetrack video is that you set the sidetrack and you go through from a place. And then if you need another sidetrack, that for sure you can do it, but shallower. You can go shallower and do another drain. So you have many windows into the same mother hole, and it does not really weaken the initial well, because it is well isolated, and you do all the necessary assessment to make this deviation. So no, but good question. Yeah,
Mr. Khaled, I have a question.
sure.
Uh, what advice would you give to someone starting their career in drilling engineering?
All right. The advice is basically don't worry about, I mean, you need to think about the future for sure. There must be kind of like the future is ahead of us, and there will be still drilling needed. Connect with your faculty members, attend forums, enroll in these SPE programs, and reach out to young professionals in order to understand and take some insights from them. So this is basically your network is your net wealth, right? Uh, you need to have connections, connect with the experienced people, and just like be aware of what's happening there in the industry. Um, the SPE is really a great medium. You can check the journals from the SPE websites, and you can know what technologies are in there, and just like get enrolled with any of these forums and the conferences being held in ADIPEC, and I can't remember all the namings, but there's plenty of forums that you can attend. So drilling engineering is very interesting. I wanted to do something actually in drilling engineering, but unfortunately my career path was different. But it's very interesting world to be, and you need to be very strong technically.
There is, I think, another question from Al-Bahi.
Mhm. What are the
What are,
different,
yeah,
yeah, what are the different challenges or problems that the drilling operations suffering or faced it in this period, or they are working on it to find a solution? Drilling operations. So I know like some of these for drilling operations, especially for the underreaming. When you are placing this underreamer on top of the BHA, you are for sure you are enlarging the hole, but at the end you reach the total depth, okay, and you are leaving behind you kind a lot like a long distance from the bit to the underreamer, which is it can extend to 100 feet or more. So this is left behind you as a rat hole, as not unenlarged, a hole. So nowadays there are some technologies to get this underreamer really as close as possible to the bit. Another challenge is basically the current rotary steerable systems, the RSS, what we call, is nowadays placed above the bit. But in order like to get the best steerability way for these RSS nowadays, and you can look it up, it's called the neo steer or something similar. So some companies developed kind of like the rotary steerable is now embedded with the bit itself. So what they are trying to get those steerable system as close as possible to the bit for the maximum efficiency for steering needs, right? So the more your steerable system is closer to the bit, the better for you in order to navigate and in order to geosteer. So problems faced as well, you have in the extended reach wells, you have a lot to drill, and you were like a long time ago you were drilling, but you don't see really where the hydrocarbons are placed. So now the company started to develop like reservoir mapping tools in order to see where exactly we need to call the end depth, the total depth of our well. So this will be creating kind of like efficiency and optimization of the well placement. So there's a lot of problems in there, and for every problem, there is an increased efforts to come with the suitable challenges with the less chance of risk or failure. So these are the main things and topics happening for the drilling operations. I hope I answered that. Yeah.
So any questions? Any other questions?
Fakhruddin, you said you have one, right?
I already done.
All right.
I think we should conclude our session.
Sure.
Thank you, Mr. Khaled, for sharing your expertise and insight with us today. Your perspective was truly enriched our session. We appreciate your time and hope to welcome you back in the future.
For sure, anytime. And it's a pleasure to be with you today as well. And thanks for you, and thanks for Yahya for arranging this as well.
So thank you all for joining today's session. Appreciate the engaging discussion. Have a wonderful day.